Hello everyone, welcome to my talk today, From Emulation to Assurance. My name is Jose Barajas, and my goal for today is to share what I have learned in my career for the last 7 years. I've been doing this continuous security optimization, so I want to share a little bit about that today. Specifically, how I'd like to talk about the problem all of you are involved in from an adversary emulation perspective. Essentially, you're providing the solution to the problem of controls not working effectively. So I want to talk a little bit about how I like to talk about that problem and share it with folks. I think that might be useful for you. And to be honest, cybersecurity is getting harder every day, and the work that all of you do is helping us drive towards a safer, future together. And this is my way of sharing my experience so that you could apply it. These things and make your organization safer every day is the hope that I have by presenting to all of you today. So with that in mind, let's talk a little bit about me to start, so you know my background and kind of where I'm coming from. And my name is Jose Barajas. I am from San Diego, California. Not technically born here. I was born in Los Angeles, but I've lived here my whole life. Love San Diego. For those of you that haven't visited, definitely check it out. And normally I'll throw this in here. I did it today because I don't think it snows, at least not that much in Texas. But because I'm from San Diego, I've never had to shovel snow in my life, which I like to always bring up when I'm talking to folks on the East Coast. Now, for me, I'm currently the technical director at AttackIQ. At AttackIQ, I lead the sales engineering team there. I also lead the research that we conduct with MITRE's Center for Threat Informed Defense. I have a background as a researcher prior to that, so that's kind of how I landed there, and we'll talk about those projects a little bit later. My favorite technique ID is T1003. Super simple one, credential theft, specifically Mimikatz is what comes to mind as I mention this. And the reason for that is actually multiples. For one, the fact that someone wrote Mimikatz just because they wanted to learn how to program, I think is an amazing thing. Two, the fact that Mimikatz is such a brilliant technique, but we just still see it being successful so much even today, are one of the many reasons why I like this technique ID. This is like I described it, it's part of the basics. And to me, as we do adversary emulations, absolutely, let's emulate attacker behavior, the latest and greatest. But at the end of the day, let's make sure that our basics are working. And a technique like this really reminds me of those basics. All right, even free antivirus should be stopping Mimikatz, as an example. All right, enough about that. How I got started in cybersecurity is actually quite interesting. I was originally a web developer, and then Flash became a problem. So Flash exploits, for those of you that know what Flash is, I think it's definitely deprecated at this point. But essentially, because I used to know how to do action scripting in Flash, I knew how to break it down, and that was kind of my entryway into cybersecurity. I had some great mentors along the way that taught me a little bit more than that, but that was my first kind of transition into cybersecurity is through Flash. And that's why I'm here today. My work was spent 10 years doing research. So I have a researcher background and spent my time doing reverse engineering of malware, studying CNCs, applying, what we call buzzwords ML AI today to understand those patterns. Develop sandboxing technology and a variety of different malware analysis approaches that we developed there as well. Now, my last 7 years have been spent here at AttackIQ doing security optimization. And of course, I'll throw in a disclaimer, right? The views here are my own. And right there on the right, that's me with my two pups. On my left on the bench is Goji. And right there in front of me, that's Goose, his little sister. So those are the two dogs that me and my wife have, my wife Elizabeth. That's me, team. So let's go ahead and just jump right in here. Now, the agenda for today, first and foremost, I want to talk about the problem that we're solving by actually going through the adversary emulation process that all of you are learning about today. I want to talk about why it's so important that we address this problem that you're helping with. I then want to talk about how we've actually solved this problem before and how the work that you're doing actually contributes to this solution. Right now, you'll see in a moment, we've solved it before in other spaces, but nonetheless, this concept of adversary emulation, I think, has a direct correlation, as you'll see once we get to that. Beyond this, I want to share stories from the work that I have done with organizations. So I'll share some stories with the field so you can see the type of findings that we've had and how organizations have actually responded to that. And then finally, our mission here at AttackIQ is to make the world safer for compute. And one of the ways that we do that is by trying to give back to the community. So I'll share some resources that we have that are in alignment with some of the topics I'll talk about today, so that you can have some follow-on items to look up, so that you can see a more deep dive into the concepts that we'll be talking about today. So let's go ahead and get started, and first and foremost talk about the problem. And the problem is really about the confidence that we have in our security controls. So before I actually get into it, think about it. Rate your confidence in your security control effectiveness, right? Given that you are all here for the Adversary Emulation Village, I'm sure you have a good sense about what that posture actually looks like. So think about that. Scale of 1 to 5, right? 1 being pretty bad, really bad. 5 being I'm amazing. Nothing will get into my environment, right? What's your confidence in your controls capabilities? Now, to start, I always like to talk about this is important stat is just how much money we're actually investing in solving the problem of cybersecurity. It's great for us. I always like to joke with my old colleagues, we'll always have a job in this space because things are continuously changing, right? That's actually why I love doing what I do here. But the point of bringing up this stat is as much as it's being spent here, and this is a Ponemon group study, 53% of IT security leaders don't know if their controls are actually working. And this is a staggering number considering how much is actually being spent by these organizations. And today most organizations rely on, manual partial assessments to validate some of those assumptions that may only cover a really small portion of their environment. I think what the takeaway I want you to have from this is essentially, these executives, these IT leaders, I think they do have an understanding that we definitely need to do something here. There's definitely a gap, and there's definitely some concern. So something to consider as we're engaging and trying to get investment into the type of work that we're doing here at the Adversary Village is, they do have a sense of this as well. It's just a matter of, talking about it and then bringing it up in a way that aligns with their concerns, right? And another stat that I really like to talk about when I'm trying to talk about the problem here, which is we need to make sure that our controls are working, essentially, is that 82% of breaches should have been stopped with existing controls, but really weren't. And Verizon, for I believe the last 6 years, or for as long as I can remember, has been producing this stat. And if it's even half true, that's a huge problem. And most organizations had deployed a security control that could have prevented a breach, but they just simply weren't properly configured. And we call this a protection failure. You'll hear me use that word, protection failure, throughout this presentation, but that's essentially what it means, right? The right capability was there, maybe even the right configuration or policy was applied, but for whatever reason, it wasn't appropriately configured, deployed, or provisioned, and that gap was actually still there. And security teams must identify these protection failures before the adversary does. This is because security products rarely are integrated, they're very complex, and you're spending money on all this capability, but it may not be working correctly, or if it is today, it's not necessarily working the same tomorrow. So I'll ask you again, right, to rate that confidence, right, from 1 to 5, where do you actually stand? And given what you do, I think you know what the reality might be, and hopefully at this point some of those items you've addressed. But the feedback that I typically get when I do ask this question really varies depending on who I'm talking to. There's really quite a spectrum of the feedback that we get. Starting with, my stuff works all the time. These are folks that think that everything is perfect, everything's working, and that nothing is ever going to change, right? From there, we have folks that are, well, I hope it works, right? Maybe, think that everything should be working and that's good enough for me. Another way I like to describe that, actually moving on to the next one, right? My vendors confirm that their products are rock solid. So, definitely pointing at, I bought the best in breed, so I must be okay, right? We're doing pen tests, so I think I'm okay. And this is good. Pen tests are fine. We all want to do and should do pen tests, but these are point in time. So, especially if you're only doing one every once a year, maybe not, shouldn't add too much to your confidence because of that, right? And, I'm not sure I really want to know. I've heard folks share things such as they don't want to know because it means they have to do something about it. Said differently, and the way that I like to describe it is that ostrich with the head in the sand, right? Don't want to see, don't want to know, let me just put my head in the sand. If I don't see the problem, it means that it's not there. And it's just really not an appropriate approach for dealing with the problems that we might find. And you'll find a different plethora of other reasons that folks might back up and really say, my baby's not ugly, everything works here. And I will say, given the conversations I've been having, I think people are more open to actually be accepting, be understanding, and essentially be okay with saying that, I know my stuff isn't necessarily 100% perfect, but that's exactly why I want to be proactive and ensure that those things are working by doing these other processes. Now, so far I've talked about the problem. Essentially, our confidence is low in our security controls. Horizon is telling us that the breaches that do happen, we could have stopped them. So how is this actually manifesting itself in your environments? First of all, if we look at this chart, all this stuff has to work together all the time to be an effective control within our organization. And there's a variety of different modes of failure that might happen across the different control capabilities, technologies that we manage, whether they're solutions that you get off the shelf, whether they're solutions that you build in-house in our custom processes, as an example. All of them have to be working together and effective. And as other folks might say, the attacker only has to be right once. And the way that it manifests itself across different technology stacks, things like endpoint, as an example, might have logging reliability. Things like endpoint logging might not be turned on, so it's not showing up in my SIM. The endpoint isn't being deployed correctly. Folks are misconfiguring it all the time. Or there might be application updates or conflicts as you get those different updates. And the difficulty is that I've seen in some organizations, they can't keep more than 80% of the estate covered with these agents, right? And it has nothing to do with the ability of these technologies to function or operate or work necessarily, but it's really hard to get coverage all the time everywhere. Different stakeholders might control different parts of the business, and they'll tell you, I'm not going to let you install your stuff here, right? It's really a variety of things. And another example here, application updates and conflicts, and we'll talk about this one a little bit more later, but we have a unique situation with one of our healthcare customers that I've talked to, where they have nurses' workstation laptops. These are assets that have access to PII and other healthcare information. So it's very important that these assets are very well protected, but they go away for quite a while depending on what occurs or what happens. So what that means is those applications aren't necessarily up to date and aren't the best to necessarily protect the business, as an example. Now, beyond that, right, on the networking side, we have the same kind of reliability problems, right? Maybe for whatever reason, a firewall goes down, logs aren't being forwarded correctly, maybe even physical things lead to packet loss, or we're not getting all the context that we thought we were getting or we expected. And the way that this might manifest itself is something hot might come in. We might go into our technology directly, say the firewall. We might go to the SIM where these logs should be forwarded, and nothing comes back. And as an analyst, you ask yourself, is that because we haven't actually observed this IOC? Or is it because we weren't actually logging as expected, right? And that leads to this investigation that finds that for whatever reason you didn't have visibility into a different part of the business, as an example. All right. From there we have asset management. Asset management is hard. It's a problem that we're still trying to manage in IT today. And not only are we facing asset management problems, but new types of assets with a completely different set of considerations are being created every single day. I actually just upgraded my iPhone, for example, and realized I had 5G. And when I did a quick test of the speed, I'm doing 200 megabits per second. That's a lot of data that can be transferred real quick with that amount of data transfer capability as an example. So that's just one example of how technology really needs to change the considerations that we have when protecting our organizations, right? Moving along here, things like threat intelligence, simple as are we focused on the right thing? Intelligence grooming has to be focused on the right thing to be effective. And then outside of this, I like to say everyone is an application developer today. At the end of the day, every business needs to develop an application, either to provide their services directly, either to support their business internally, or on the security side in order to actually support the work that we need to do to protect the businesses that we work for. And this is actually, this adversary village is a prime example of that. A lot of folks today have either built these technologies or are teaching you how to grab them and put them together and how to manage these applications. And that's just another thing that we have to manage. Things will get out of whack as updates go along. So these are things that would need to happen to work and work effectively all the time for us to be successful. Now, I went through quite a few different slices across the organization of how we might find failure and how this failure might manifest itself, leading to the problems that I described. At the end of the day, assuming we get everything right about what I've talked about so far, the human is still the weakest link, right? We can do all the training and readiness that we want, but attackers are really good at getting crafty with the emails, the messaging, using the appropriate names and context that we interact with on any given day. And because of that, the human will always be the weakest link. And I just bring that up to say that everything can be working together, and then someone opens up a payload that is 0 day or the latest attack, and all of that, not for naught, but still, just to show you how even the best planning can have a gap there. Now, while we have a method for testing, they simply don't do enough. So the skills being taught today are important. What you're learning in other talks today about how to apply this technology, how to implement it yourself, is going to be very important as you progress here. And if we go through and we take a look at the impact across the organization, the way it ends up manifesting itself is going to be very different from for example, the threat management group. Today, right, they might have limited tradecraft. The focus today might be on things like IOCs, which are simply too temporal. From a threat management perspective, some organizations might not even have this capability yet. Might be considered a luxury even. And then finally, there's not a standardized approach to the discipline. With that said, things like MITRE's threat-informed defense, which we'll talk about Academy at the end, can kind of support you that's changing, but still, at the end of the day, the way it manifests itself is you don't necessarily know what you're up against. From there, if we take a look at the risk management side, they're really looking at things from the perspective of risk, but these risks may be misunderstood. Right, the assessments that they might use to evaluate the risk might be weak, given the understanding of the risk as an example. The focus really being on compliance and not security, and I think there's a continuous debate in our space. If you haven't heard folks talk about that, definitely Google compliance versus security, right? Beyond this, there's point assessments. And often, not efficacy informed, and you end up making bad security investments if, first and foremost, you didn't know what you're up against, and then secondly, you're not evaluating the risk correctly. And that example with the healthcare organization and the nurses' workstation laptops is an example of why it's so important to actually understand the way that the business operates. And I'll actually make one last point here around risk management. A lot of folks in these roles, if the risk gets a little bit lower, they also end up getting a bonus. So incentives matter as well. from that perspective, I want you to keep in mind, especially the hackers that are attending here today, those incentives, we can also use them to make them invest in the things that we need to do to make our organizations safer. So keep that in mind as I bring that up. Now, moving along here, right, from a security operations perspective, if the items in the left are not in place, this is going to lead to growing dependence, to unlock technologies, transformation for the business, right? Differentiation. So our security operations need to continuously change. Monitoring controls are not often well exercised. This is manifesting itself as alert fatigue, right? We want to reduce and focus on the things that matter. And again, the complexity of the ecosystem is continuously growing. The business is operating with different technologies. And what that means is a lot of noise means you end up missing the incident. And really the two things on the left need to be right in order for you to find the right incident. So just the complexity of these different units just really doesn't help us. And finally, from a security testing perspective, it's actually really costly to test on a continuous basis, at least the way that we have been historically. Things are also too temporal because it's costly. We're not doing it all the time. We're not doing it everywhere. There's also varying quality, right? And what I mean by that is someone might be really, really good at application exploitation, while someone else might be really, really good at the endpoint and moving laterally and persisting or whatever that might be. So not only just varying quality of overall folks, but just focus areas, right, as well. Finally, scope and the orientation dependent. So as you define scope, again, if we go back to risk management, selecting parts that are going to show a little better, that's really going to affect what we think our posture actually is. And then finally, these things are often not repeatable, so it just doesn't do enough. And to give you an example where we are today, one organization that I work with, their red team can only cover about 1% of the topology per month. That means that they cover about 12% per year. And the business is actually doing really good, so they're never going to get better. Meaning the business is going to continue to grow, generate more offices, more server farms, and the red team investment is not going to match the acceleration of growth of the business. So only through the capabilities that you're learning here today, the tools and capabilities that they're presenting to you, are we going to be able to keep up and actually do enough and give ourselves the ability to scale and have additional functionalities across the business, right? And another customer only has about 5% topology with their red teams today, as an example. How confident can you be if you're only actually testing anywhere from 5 to 12% of your topology, that the entire estate is actually being managed well and that our controls are actually working correctly? So now let's actually talk about the proposed solution here. One thought is that it's really a conceptual systems engineering problem. What we're looking at here is actually the cockpit of an airplane. And you see there's a variety of different knobs, there's a variety of different lights, and there's also a variety of different measuring devices that are giving continuous feedback to the pilot. And I'm sure that if either of those 4 little green lights, if you see those on the right, turn to yellow, turn to red, turn to any other color, the pilot has a very clear understanding of what that means and what corrective action, if any, he needs to take in order to address the problem that might be signaled by that change in color, by those little lights that we see there. This is the feedback loop that we're missing in cybersecurity today. And different processes like adversary emulation are the capabilities that are providing that context back to the SOC so that they can understand what the true reality of the environment is, not just based on assumptions. So as you go ahead and test certain capabilities, as you establish a process for this, it's really providing the feedback loop that the security team was missing in order to ensure that everything is working correctly, everything is within specs and as expected, right? I know they have sensors for things such as the wings being frozen, all right, because frozen wings are probably not going to work effectively. So they have a sensor for that, so that if it does happen, they know about it, could just scrape that off and then be on with their lives, right? Again, that's exactly what we need in cybersecurity. And the adversary emulations that you're running today or that feedback loop back to the business to help ensure that things are working correctly. Now, another thought, and this is where I say we've already solved this problem before, we really don't need to reinvent the wheel. And the analogy I like to use, and if you look there in the bottom, you can see there's a talk at RSA that used a simple metaphor of fire by John Elliott. But essentially, the point that I got from this is, just like we manage fire today as humans, we need to manage our cybersecurity programs as well. And what I mean by that is, I live in a building with, it's actually 6 buildings. I believe there's over 3,000 people that live in this building. And we have pipes similar to this. I don't think about it. I don't have to worry. But I do know that my building, the regulations, the fire department knows the mean time to failure, the mean time to remediation of each and every one of these systems. What that means is the fire department, even though I don't think about it, if in the office building, for example, as well, they go in and they know that these things have a potential to fail every 8 months. So they come in at the 6th, 7th month, whatever they may be, to do an inspection, do a proactive maintenance on the given hardware to ensure that when a fire actually hits, those sprinklers are actually going to go off and they're actually going to turn it off. These are the type of processes that we just simply don't have today in cybersecurity. And again, the work that you're doing as part of the adversary emulation process that we're discussing today helps provide some feedback and insights into the capabilities. And if, for example, you notice that you're testing every month and for whatever reason, this thing just keeps going back to just not blocking, taking a deeper inspection, understanding why that is. And now maybe we know we test every 20 days to make sure that we don't actually spend any time without protections, as an example. And all of us do it today. If you don't remember the last time you checked your own smoke alarm at home, I recommend you pause this right now, go to your smoke alarm and check to make sure that it's still able to beep. But this is just another example of something that we have in our lives today that helps keep us safe. In this case, gives us a detection alert or an alarm to let us know that there's smoke. And that probably means that fire is really close by, so we should do something about it, right? Again, this is the feedback loop that you help provide as part of this process to ensure that all those things are working correctly. And this process that we go through is being described here, where essentially let's go step by step and recreate the threat that we expect. This is actually going to be done by applying a threat-informed defense. Something that you can learn from our academy or from MITRE directly. Those of you with threat intel shops, you might analyze something, and in this case we're talking about an energy utility vertical as an example, and we want to emulate APT33. So as part of this process, the testing or pushing of the smoke alarm starts with your red team, right, going through every one of these steps and providing that feedback back to your blue team in order to define that construct and that workflow in between the teams. Here, right, starting with PowerShell, we have the logging that's going to help provide coverage and visibility, so on and so forth as we step through the attack. This is the process that's going to give that feedback loop back to your organization. The lessons that are learned here can then be applied to ensure that the organization is safe. And the last thing that I want to leave you with here is essentially this flow. As you start to get a cadence, as you start to get an understanding of what that flow looks like, you can start to go from these things that are either very point in time or very resource intensive, essentially manual red team exercise as an example. Going from doing things manually or script-based testing as part of a purple team workflow to ideally automating this. And the idea is that the more and more we can automate, the more and more we can include as part of a process so that we can test, say, every day for something, right, versus maybe once every 6 months. You start to build up this cadence as a business, as a team, to actually focus more and more on the interesting stuff, right? As red teamers, we want to continue to do our red teaming. As detection engineers, we want to continue to do our development of logic to make sure we identify attacker behavior. The tools and capabilities that you're learning today here at the Adversary Village are going to help you accomplish this and move closer and closer to having more items under automated and continuous, than those things that are point in time or simply take a long time for you to complete. And ideally, we'll get to the point where, just like the analogy I use with fire, we have a very clear understanding for every single control to what degree we should be testing, at what cadence we should be testing, and what are the gaps that we should be looking for. All right. Now let's talk about some of the stories that I have from the field. These scenarios are really meant to serve as an example of adversary emulations being applied, the outcomes that were identified, and the solutions implemented by the organizations that I was working with. I hope this inspires your work and the teams that you work with directly or other parts of the business, so that you can foster that same synergy that I observed with these organizations. Okay? Let's start with this first example here. And the first lesson here is really know your business. And I already hinted at this scenario earlier before. And in this case, we're talking about a hospital working with a hospital organization, and we're testing a variety of different environments, one of which was the environment where the nurses' workstation laptops were being held. This is actually an environment that was joint managed with another business, and they actually owned the laptops themselves. The interesting thing that came out of this is they were finding that these laptops were either outdated, not blocking things like other parts of the business, or were actually going offline for quite a while as they were looking at things from their controls perspective. And what they were able to find is the way that the process works for the nurses is once they're actually done with a workstation, they go ahead and put it on the shelf. What that meant is it could be on the shelf for a matter of minutes or hours, or it can be on that shelf for months at a time because it just sat there. No one got to it because not that many laptops were required. What that meant is the laptops were now out in the environment, not fully patched, or if they were in the process of patching maybe. But what that meant is the control capabilities weren't fully there. That led the organization to now establish a process and protocol around this, where if an asset is offline for more than, I believe it was 14 days or so, they're actually going to run a full suite of tests, a predefined set of tactics, techniques, and procedures, TTPs that they'll execute on the box, in order to verify that what they expect from that system is actually working as expected, right? What should be prevented, what should be detected is. And we know that it is because we tested for it. Also, as new laptop workstations are actually provisioned and provided to the nurses, that same testing is going to be applied as the gate prior to them going to production. And I call this really know your business because this is a very unique testing criteria that needs to be applied given the way that this unit actually operates. So always consider that, right? How are the folks actually using the technology that you have monitoring capabilities over? And take that into consideration as you define what you want to test for and how you want to test things as well. All right. Now, this next lesson aligns with the, always test the basics, which is something that I think I've brought up a few times on the talk already. And, in this case, we're actually talking to a municipal network, a network, I should say, with a municipality, is better said. And essentially, as part of the engagement, we wanted to do some basic exfiltration and basic tests of the boundary to make sure that their boundary infrastructure was actually working correctly. What we did there is we did a variety of different exfiltration techniques, exfiltrating data over a variety of different protocols, as well as actually trying to see if we can get some payloads into the environment. And I always like to start by testing the basics. What we're able to find is that the exfiltration behavior and basic payloads, even things like the ICAR file, were actually not mitigated or logged. What we were able to find is that the firewall is actually configured to the default settings, meaning allow all. So, from that perspective, this just highlights the importance of having proper logs, and also the importance of ensuring continuously that our policies are actually configured as expected. So what the team decided here is instead of taking a chance of having downtime where they actually don't have visibility into things, let's do a simple test every single day, basic web request of an ICAR file to make sure that the firewall is working effectively. And why this might be super simple, it's not as sexy as doing adversary emulations and doing red teaming, But that basic capability that identifies that file and actually cuts off the connection is the core functionality that is applied to more complex behaviors by a security technology. And I say this with experience building technologies in my background. So this is why it's so important to test the basics. And a lot of times when we find a basic that is not actually addressed, it typically means that there's some massive misconfiguration that we probably need to address. And in this case, they were able to do so by applying some continuous testing. All right. Now, the final item that I want to talk about is actually a financial organization. And, the lesson here is potential points of failure never fail to, fail. And in this case, working with a financial organization, we're actually testing within their ATM cluster. These are special networks for these ATMs where they have microsegmentation. They don't want ATMs to talk to one another. And what we're able to do here is actually find some target assets to test in. And out of all the assets that we selected randomly, one of them, we were actually able to successfully steal credentials. What I said is, okay, well, let's see what we can do from here. So we went ahead and attempted to steal credentials again, and then use those credentials to see where we can move laterally. So we did a simple scan, identified 180 other ATM servers. We were able to successfully establish communication, I believe it was through WinRM. Use that to copy a file over, to 60 of those assets. Those are the ones, 60 or so assets that we were able to move laterally to. We copied over a file from the original asset, and we exfiltrated that data over DNS. This is all from a single machine, being able to discover those 180 to those 60. And the problem here is none of the ATMs should have talked to one another. The asset should have blocked these basic Windows credential theft like everybody else. This is why I really like Mimikatz. You'd be surprised how many times we find it working. And this is also, an example of why we want to test, these production assets and not just pristine gold-disk images as well. But in this case, essentially, none of this was logged. The segmentation didn't actually work as expected, and the SIM was not, context was also not being forwarded either. At the end of the day, the problem was not the fact whether they had the right technologies or whether they had the right configurations. It was actually a provisioning problem. This is what I like to call out as a potential point of failure. If you're managing unique boundaries, say different offices with different firewall boundaries or DLP boundaries, if you have different provisioning processes, as an example, each one of those unique processes is a potential point of failure. And in this case, that asset was put into production without basic endpoint technology installed, meaning no AV, no group policies were actually applied, hence why we were able to make this finding and discovery in this environment. So from that perspective, when you consider where we should be testing, where we should be replicating the testing, always consider the potential points of failure that you have within your organization, right? Where are unique processes being managed by different parts of the business? Because we want to test there to see where there might be a problem so that we can address it in a proactive fashion. All right, team. The last thing that we're going to talk about is some resources. I want to end by providing you some resources that I think are quite useful. These are based on the work that I do both here at AttackIQ and the work that I do through AttackIQ with MITRE directly as part of the center. So let's get started by first of all talking about the AttackIQ Academy. As I mentioned earlier, here at AttackIQ, our mission is to make the world safer for compute. And by providing you resources here in Academy, and it's academy.attackiq.com, you can actually come here and take a number of courses. They're all free for anybody, and you actually get free CPE credits. These are self-paced courses that are instructor-led, where you can actually go ahead and take the course at your own pace, on demand. And if you give us your ISC Square membership, you actually get CPE credits as part of the process. And we have courses ranging from operationalizing MITRE ATT&CK, how to actually conduct port teaming, both as an analyst and as a manager, and how to do breach and attack simulation, which is what the nomenclature for the space adversary emulation is being called by folks, right? By Gartner. And then we also have other assessments, courses, I should say, around things like security stack mappings, which I'm going to talk about a little bit later, and control mappings as well. These are two research projects that we were involved in. We have some courses that walk you through those as well. Beyond this, some recommendations that I have is, strategic cybersecurity management. If you want to get perspective of cybersecurity leaders and executives in the cybersecurity space, this is a great way of getting that perspective through that course. Something practical that I would suggest is actually learning how to use MITRE ATT&CK Navigator layers. This is actually a tool that MITRE developed to let you track MITRE technique IDs. It's a great way of documenting things. So as you're going through your adversary emulation process, you can plan on this or even document things on this as well. And we teach you how to use that. And then finally, if you've never done adversary emulation yourself and you're listening to some of the talks here today because you want to get started, this is actually a course that I produce, Fin6 emulation plans. Based on the work that we did with MITRE, I walk you through that project and teach you how to do some basic emulations, and all you need is a command prompt. So if you want a starting point for adversary emulation, highly recommend you take that course. Now, beyond the resources that you find on Academy, and that's academy.attackiq.com, we also have some resources that were produced as part of the research with MITRE Center for Threat Informed Defense here. And the three research projects that I recommend you look up, and if you look there at the bottom, you can go to the core GitHub repo and see these and other projects. But the first one is adversary emulation plans, which actually defines different threat actors and how to emulate them. The security stack mappings, which actually gives you mappings to all control capabilities. And then finally, the control mappings, which is mappings of all MITRE technique IDs to NIST 853. So let's take a quick look at those here. From an adversary emulation perspective, each of these adversary emulation plans are actually going to provide you a quick summary of what this attack entails, the phases and step that attack takes, so that you can quickly understand how this threat actor operates. It even breaks down essentially the detailed step-by-step actions that are taken down to the procedure, essentially the exact commands that we're executing, to even include alternative procedures that you can execute, assuming you're not able to execute one of the first ones. They have things for APT29, Carabank, Fin6, Fin7, and MenuPass, and it's also a model that you can follow to develop your own as well. The second project is the stack mappings, and as part of the stack mappings, we did this for AWS and Azure. We took all known control capabilities for these cloud technologies and mapped them to NIST 853. So as you find a gap, say in one of these cloud controls, or as part of your adversary emulations in the cloud, you have here a reference that your team can use, and it goes through, down to scoring the degree to which a control provides coverage. You have something that your team can look at in terms of resources that are available. For example, did you know that Azure has 48 unique controls, and they're actually all mapped to MITRE technique IDs here? So great resource for you as a team. Now, finally, we have here control framework mapping. These mappings of the attack techniques to NIST controls provide in the simple conceptual format. This control can be implemented to mitigate this technique. Said differently, you can actually leverage this to look at a MITRE technique ID that you maybe have found a gap for and translate that into the NIST 853 control, so that when you're describing this to the CISO or CIO, they can actually look at it from their perspective. We have our threat perspective, they have the risk perspective, and this project bridges the gap for you so that you can communicate effectively with your leadership. That's all I have for you all today. I appreciate your time. If you have any questions at all, please feel free to reach out to me directly here or ask any questions through the Adversary Village as well.